Good morning, everyone, and thank you for joining us today in the final week of the Inspire on Sustainability series. Really excited for two speakers that we have on this morning that join us, and I'm just going to introduce them to you now. So first of all, we have Vannessa Goodship, and she began work in a plastics laboratory at just the age of 16 and was instantly hooked by all of the fascinating materials that she saw before her. She has over 50,000 academic reads of her 2007 paper, giving an introductory overview on plastic recycling, as well as publishing further works on recycling-based topics, which can all be found on her Amazon author page, and details, of course, will be on the cheat sheet. She works in the UK as an associate professor for WMG, University of Warwick, which is the base for the National Polymer Processing Centre, and the WMG Centre High Volume Manufacturing Catapult. Also joining us this morning is Helena Simmons, and she works as an innovation manager with the SME team at the WMG and the University of Warwick. Here she collaborates with local industrial partners to grow their business through technological innovations. After joining WMG in 2013, Helena worked in the Automotive Composites Research Centre, developing manufacturing processes such as preforming and compression moulding, as well as using mechanical and thermal technologies to analyse and validate the mouldings. Now working in the SME team, Helena is focused on helping local manufacturing companies adopt sustainable manufacturing practices. Of course, our speakers this morning are joined today by Jude Pullen, who is creative technologist and physical prototyping expert, and will put all your questions forward at the end of this session. So as always, please do get those questions in the Q&A box at the bottom of the screen that you see, and we'll get to as many of those as we can this morning. But for now, I'll hand over to Vannessa and Helena. Thank you.
Thank you very much, Nikki, and hello everybody. I am Helena Simmons, and Vannessa and I today are going to talk to you about plastics, and hopefully you won't think of them as a villain, you'll think of them as a hero by the end. So just quickly going over how we're going to present today, obviously introductions, and then Vannessa's going to take you through the majority of today's talk, talking around plastics, some background, some design rules, some information about how they can be used in the circular economy, and then something about the future, looking at bioplastics and other materials. What I'm going to do is take you through a case study of how we've helped a business reduce their plastic waste, and this is using the GROW model. But I'm going to invite you to kind of work along with me while we do this. So if you do want to join in, have a think about a topic or a problem that you'd like to tackle in your work life. And we'll go through the GROW model just quickly over 10-15 minutes, but set your conundrum now. And then finally, just at the back of the presentation, I think more for the slides after at the end, we've got a load of examples and cheat sheets to help you. So that's it from me till later, and I'll let Vannessa take you through plastics. Thank you.
Thank you, Helena. Obviously, my name's Vannessa, and I love plastics. So before we start talking plastics, I think it's important to clarify why we've entitled this talk about net zero. Net zero refers to a state in which greenhouse gases going into the atmosphere are balanced by the removal out of the atmosphere. The CO2 emissions, this is a state at which global warming stops, and the UK aims to be net zero by 2030. The circular economy, on the other hand, is a model system which involves processes such as reusing, repairing, refurbishing and recycling. In this way, the life cycle of our material and the resultant products are extended for as long as possible. So how do these two states overlap? Does eliminating waste plastic and using plastic recycled actually help us get to our aim of net zero emissions? Well, let's have a look. The most significant emission savings can be made by adopting alternatives to producing new materials. This is not just plastics and includes the production of other materials like steel and aluminium. Here, the circularity is also being currently investigated. And like plastics, by using methods such as recycling initiatives. Therefore, paradoxically, the increased use of our existing plastic materials could actually reduce the overall consumption of fossil fuels, and therefore society's greenhouse emissions. One final concept I'd like you to consider here is the cucumber. If you shrink wrap a cucumber, it extends its life by 15 days and therefore aids in reducing waste food emissions. So, if we can adopt a more sustainable approach to food packaging, plastics could continue to contribute to a solution for our aim of net zero. Now, I want you to imagine a world with literally no plastics in it. And this is exactly what researchers did in a study in 2010. So imagine 20 to 40% of all components in your car are made of plastic. Imagine how heavy cars would be if these could be replaced with something like steel. And there is no non-polymeric replacement for safety airbags currently available. So there'd literally be no safety airbags in cars. Aerospace interiors, and more recently, some aerospace body structures are mainly plastics, plastic composites, and again, make the overall aircraft lighter. Could aircrafts fly economically without plastics? If you consider composite wind turbine blades, no composite wind turbine blades would mean we couldn't support the weight of the materials. We'd have to make them smaller. We'd have no squeezy bottles. You can't do that with a glass bottle. No blood bags, no artificial heart valves, no polymer implants for surgeons, no polymer separators for batteries. The list actually goes on and on and on. And of course, there'd actually be no Lego. Did you know there are already 80 pieces of Lego for every person on the planet? And if anyone's interested in Lego, it's actually World Brick Week this week. Links to both Lego and Mattel sustainability can be found in the extra resources at the back of the slide pack. We have included a lot of extra information for you, which you can go back and look at afterwards. Plastics have played a key role in the COVID pandemic, supplying both materials and mass production for the global population. We would simply not have been able to mobilise a response so rapidly without plastics. Used to mass produce the lateral flow test, machine parts for incubators, and PPE such as visors and gloves, to name just a few. So actually, isn't this less about plastics and more a problem of packaging and single-use plastics in the environment as the subject which needs addressing here? And I'm curious to know if, like me, you've noticed how many discarded masks there are now appearing in the environment. Have you seen any masks in your parks and streets? Let me know. Anyway, so we're now going to take a closer look at two very familiar and villainous materials in packaging, polypropylene and PET. And later on, I will introduce their biomaterial equivalents, which are PLA and PHB. So where does your plastic come from? Is it a fossil source or is it a biosource? This is a synthetic polymer, but manufactured from a renewable resource like sugarcane instead of oil. Is it mechanically recycled following a first use phase? Is some of it recycled? Is it a partial recyclate? Is it a reuse or a repurpose of someone else's PP product? Can it be made to degrade in the environment? And can it be made by being self-reinforced? Does it have other reinforcement? Is it a composite material? And you may be surprised to know you can actually get polypropylene as every single one of the above material types. There's actually often a shortage of recycled PET. And the reason is it has so many uses. Although it is produced in high volume, it's actually an engineering grade material. Like PP, you can get lots of different versions of PET. And yes, you can get it from non-fossil fuels. This is generally called bio-PET. You can get lots of different sorts of PET. You can get rPET, which has a high percentage of post-consumer waste and conforms to approved packaging regulations in the UK and EU. You already know APET, perhaps, which is one of the best plastic materials for thermoform packaging. All of these three, APET, rPET and BioPET, are all 100% recyclable materials. Okay, so why do we have this site every day? Think back to my comment on masks we have seen in the environment earlier. It's the human factor of us literally throwing them away. And like plastics, those masks are going to end up in the oceans. Is this actually a social problem of individual littering behaviour, not a material issue with plastics at all? I should note my park is also regularly full of plastics and other litter, but we have a regular team of litter pickers who now pick it up for recycling, as we often see now on our beaches. Should we be doing more to legislate against littering and encourage recycling? So you may see now of my very smooth link into my next slide. The EU has traditionally led the world in legislating for environmental protection, and this has continued to develop through progressive legislation. For example, in packaging, ELV for cars, and the waste electronics sector with the WEEE directive. Individual countries can interpret and meet legislation differently, but legislation has shown us that it forces companies to consider more than the bottom line and innovate in order to meet legal demands. For example, Italy has placed a tax on the use of virgin plastics to encourage the use of recycled materials. Some countries banned plastic bags outright. Others demanded that you pay for them. Legislation is a very useful tool to force action, and given the need for action, is more legislation towards net zero likely in the future? Okay, so now we're going to go back to my favourite topic of plastics. And I want to ask, does anybody know what this fossil fuel-based material is? I'm going to give you a few more seconds to think about it while I'll tell you some more about it, and that this material is classed as being inherently biodegradable. It is also currently used in paper and cardboard recycling and is actually added to the slurry to enhance the process. Because of its solubility, it doesn't contaminate recyclate streams for other materials, as it actually evacuates in the process. And you may regularly use it to dispense liquid or powder in your washing machines and dishwashers.
Okay, at least we have someone who thinks it might look like something from their laundry capsule, but nobody's guessed it yet. So sadly, no winners of the famed ProtoLabs design cube today.
Okay. Well, I'm going to tell you the answer, which is PVOH, which is polyvinyl alcohol. Some of you might already know this material from ALM, as it's the support material that you simply wash away after you build your model. And why does it dissolve? In exactly the way salt does. It forms some hydrogen bonds, and then it gets consumed by microorganisms in wastewater treatment or activated sludge. It's also used in artificial tears, contact lens lubricants, but more interestingly, it can be injection molded and made into films. A very, very interesting and underused material, I think. Another interesting material and application you might not have thought about is actually vulcanized rubber. So where do your treads go when your tyres wear down? What about the rubber you see left on the roads from hard braking? Where do you think they go? Into the air, into the drains, and ultimately into the ocean. This is a major environmental issue for car manufacturers, and also therefore perhaps an opportunity for designers. You're literally going to get to reinvent the wheel. Again, you'll see in the back resources there's more information on Michelin tyres, and yet another potential use for PET here. So hopefully you've had a little bit of food for thought here, and we're going to have a look at some rules. Right. This rule applies to everything to do with materials. Reducing your bill of materials not only creates less waste, but also saves you money. This is a win-win. Plastic bottles are now over 50% lighter than their original counterparts, while retaining their structural integrity and functionality. However, it is more than just creative design. There is a key role in engineering for simulation tools such as finite element analysis and mold flow to help pinpoint potential failure points, to shave off those material costs without compromising final product quality. I should also say I'm suggesting this for weight savings only, and definitely not as a way to boost sales with an inferior product that needs replacing more often. Obviously, there is a balance here to consider. But this is very relevant to the aerospace industry, where every ounce of weight in the air matters, and lightweighting is also a key driver for many other industries, such as automotive, for instance. Good design, reduced materials should always be number one in your mind whenever it's relevant to you. Right, rule number 2. Due to things like logistics, cost and markets, it's generally harder to develop markets for recycled plastics in lower volumes. Niche products and customized formulations are not really suited to the mass recycling of infrastructure. And this can be especially problematic in low volume industries such as composites, where many formulations are specifically tailored. If you can, stick to higher volume materials wherever possible. You will have more options. The exemption here is if you already have an identifiable closed loop system, or you know you can find aftermarkets. And again, there'll be extra resources to go with this slide at the back. So keep the value in your materials wherever you can. This is especially true of your materials going into more complex assemblies. For example, electronics. In these cases, repair, reuse and remanufacture are all good options to extend life here. If you can't upcycle, then downcycle, that's okay too. But keep the material in circulation wherever possible to create value if you can. You can help by keeping and storing waste materials as clean, dry and contaminant-free as possible, and protect it from UV if it will degrade, and keep track of it. Know how much waste you are creating. Reuse and repurpose is rule number 3. Can you create items that can be viably refilled, for instance? Great examples are refillable ink cartridges for printers and a refillable pod for my coffee, so I don't need to buy multiple items in either case, just one. Can you repurpose? A common example here is the yogurt pot growing tomatoes instead of a plant pot. So you don't need to buy a bespoke new plant pot. Again, there are more links in the back slides of reuse and repurpose, and learn from other people's ideas and mistakes too. If you have a busy filament 3D printer at home or office, you might want to consider a small extruder. This can recycle your waste materials back into filaments again. Though these machines are currently quite expensive for ALM and fiddling, I would expect product costs to drop and machine capability to improve in future if the market continues to expand. This is an example of closed loop mechanical recycling, which I will come to again later. So, do you have any other top tips or examples to share of reuse and repurpose? And remember, you can also reuse and repurpose people's ideas as well. I won't use the word steal here, but learn from everybody else too. Rule 4 may be obvious, but certainly needs restating. Always mark what it is. You may know what it is, but others will not. You may forget. If you throw an ALM model away, for instance, no one knows what it is but you. You need to use the relevant recycling codes and markets relevant to your sector. And without spoiling the aesthetics of your part, ideally put the material grade on there too. It really does help. For injection molding, for instance, very occasionally materials get substituted in production, and material markings which are inscribed on the tool are sometimes wrong. And a recycling study commissioned by RAP in the UK found a few parts mislabeled when looking at e-waste, for instance. And always think traceability. This is a big driver in materials as we move towards digital manufacturing. For rule 5A, I want you to think about colour and aesthetics. Carbon black causes problems for plastic sorting machines. They use a technique called infrared spectroscopy. Carbon black can mask the signature of the generic polymer and therefore make plastic sorting less efficient and cost effective. Sorting technologies are currently an area of intense development around the world. And AI and machine learning are helping recyclers develop more advanced and efficient plastic sorting machines every day. Another thing to think about is that one customer's distinct Pantone colour often does not translate into someone else's choice of product colour. If you put less pigment in, generally compounders or colour matchers will have more scope to make new colours with your material. This is literally like having pots of paint. You know, if you've got a really strong black, you really struggle to put other colours over the top of it. Again, if you have something that isn't too strongly coloured, they can be used as the base in a polymer master batch formulation, for instance. An alternative to colour is to use a tear-off sleeve or similar to leave colours a clear colour material underneath, such as we can see in the slide. My final words on this particular slide are to do with the Morpho butterfly, which you can see at the top of the slide next to the rule 5A. And the reason I put this in is because the Morpho butterfly has some of the most brilliant blue structures in nature, but actually contain no blue pigment at all. They harness the physics of light at the nanoscale, and this is structural colour by scales. Injection moulding as a process is actually very good at replication with materials mimicking the tool surface. So we can create things like holograms and microfeatures, for instance. So perhaps in the future, we won't need to use pigments at all. If you've followed these rules so far, you've created some ideas for your CE-friendly product. Here's now not what to do. What not to do. Add a finishing process which renders recycling impossible. People do this. These impacts are often overlooked. These are things to avoid. Painting a thermoplastic component with a thermoset paint, like epoxy or thermoset polyester. It's fine if it mechanically interlocks or it's peelable. If you glue, weld or fasten, think about how it can be unglued or separated at end of life. For example, if you use something water soluble, it will be easily recyclable in the mechanical recycling process. If you do need to add another thin layer or label, avoid incompatible materials. For example, don't use a PET label on a PP bottle. Keep all the generic families the same. If you do have to do any of these things for your finishing process, can you offset? Does this extend life, for instance? Does it allow reuse and repair? What else do you need to add to extend its life further? Obviously, we cannot exclude cost. And I know many of you may feel this should have been rule 1 and not rule 6. However, if you use this as rule 1, you may rule out all the other options too early and strangle your development. New materials are usually a bit more expensive to work with, and there are always teething issues. The example here introduces well-known biopolymer PLA. Innocent Drinks was an early adopter of switching from a synthetic polymer PET to a biopolymer. As you can see here, their current bottles have moved back to a mixture of bio, recycled and virgin PET. Obviously, I don't know the exact reasons behind this particular company's decision, but I can introduce some problems they may have encountered. So, as we hinted earlier, material costs. PLA would have been considerably more expensive than PET, and without a charge to the customer, this would have affected their bottom line. Manufacturing. Injection blow moulding changes from PET to PLA would not have been a simple switchover. there would have been a lot of painful learning to do and trial and error. Disposal. PLA would have needed specialised infrastructure and composting facilities, which may not have been available. PLA would have been put in and collected with standard plastic within the larger rubbish collections and would have entered a standard recycling facility, actually making the sorting and recycling of other materials more difficult. Or they may have realigned to the sustainability goals of their new owners, Coca-Cola. So while SMEs can develop into new and innovative niche brands, the big brands like the Coca-Colas and the Nestle's actually have more clout to make these changes on a global scale. But there are also targets for legislators or concerted consumer pressure. Once plastic has been collected, it will be baled and then shredded. Once shredded, it will begin a physical process of cleaning and sorting of fractions ready for decisions on next life. Light fractions such as PP, HDPE and LDPE are generally very easily separated with water using a technique called sing and float. They have a density less than 1 and can simply be skimmed off. Heavier common polymer fractions like PET, nylon and ABS sink in water. And materials that interfere with PET recycling systems are materials such as PLA, PVC and polystyrene. Also, aluminium, metallized or oversized labels, these are all to be avoided as they mask PET signatures. Any materials you have used which interfere with these systems will limit the effectiveness and hence commercial viability of the recycling process. Good alternatives to carbon black colorants, for example, as a dye, Solvaperm black, or as a pigment Graphitol black. There's plenty of scope not to use carbon black. Chemical recycling and chemical recycled plastics are really one of the fastest growing areas in the industry at the moment. SABIC are marketing materials under the True Circle brand name. And as you can see, the current chemically recycled Magnum ice cream tub is now in production. LyondellBasell will be marketing plastics produced from circular waste under the Circulen brand name as just 2 examples. As you saw in the original slide on PP, there are a variety of ways to make and recycle these materials, whether from biosources, old plastics, or even old cooking oil. If all else fails, plastics can be used in waste to energy recovery processes. An early adopter of this was used to heat homes in Paris, France, and many other similar systems now operate all over the world. It is a viable way, but final option to dispose of waste once all other resource value chains are exhausted. So compostable materials are fantastic solutions when we use them in niche products, and these are the ones that make the most of their properties. And if you want a compostable solution, there are a number of materials to choose from. Many of these examples use starch. Biopolymers are available as blends as well, with a variety of the synthetic biosource polymers we've been talking about. As I was writing this presentation, Earth First Films actually announced a home compostable packaging film, which is made from PHA. So this is actually quite exciting because the ability to home compost will make a big difference to keep composting and recycling streams separate and engage green consumers much more fully in the composting process. I think one of the real problems with composting was people wanted to do it at home and they weren't able to. So let's see how this develops. The creation of self-reinforced PLA composites actually won the Global Bioplastics Award in 2019. And again, a massive step forward for potential bioplastic application. And I think they actually demonstrated this in a car seat, an automotive car seat. So as we've seen in the example from Innocent, PLA is considered a viable biopolymer replacement for PET. And like PET, PLA is a thermoplastic polyester. It is biodegradable, bioactive and compostable. Surprisingly, we've known about it since 1932. PLA is also one of the two most commonly used materials in 3D printing, the other one being ABS. Specifically, PLA is used for fused filament fabrication. PHB, which is often considered a replacement for polypropylene, is also a type of polyester. It is bioderived, biodegradable and compostable. It is also biocompatible and non-toxic. It's actually made of bacterial strains, so is biosynthesized. To date, though, there's been a lot of issues around high production costs with minimal yields, production technology complexities, but these are under development, as we heard in the previous slide. So where is all this going? Well, in my opinion, currently this viewpoint very much depends on which sector you're sitting in. And there will need to be a lot more intersector interactions than there are now. Some new partnerships and supply chains are going to need to be formed across traditional sector boundaries by large corporations for the CE to fully develop. In terms of materials, biosourced synthetic polymers will continue to grow. These are the materials we're most comfortable and familiar with, and we have all the existing infrastructure to cope with them. Biopolymers will continue to be developed and researched and find some applications in niche areas. At some point, a breakthrough will be made in properties and cost to match synthetic polymers. At this point, biopolymers will be in a position to compete more fully. A compostable biopolymer does not present the opportunity to create a value chain in the way a biosourced synthetic polymer would, but it does have a very clear part to play in mitigating the effects of short-life, throwaway products, especially in relation to food protection. And as I've said, if consumers compost at home and take part in the circular economy, this is all the better. Excitingly, the first claim of a negative net carbon footprint thermoplastic material is already here. More will follow. I don't actually know much about this material at this point. It is called UBQ Impact, and it claims for every ton of material used, up to 15 tons of carbon dioxide emissions are saved, therefore yielding a negative net carbon footprint. No other thermoplastic I am aware of offers this environmental benefit as yet, but stay tuned, they are coming. So that was my materials bit, but what are we going to do with the knowledge? There is a concept called the triple bottom line, where you create products that are socially, environmentally, and economically beneficial. Can you extend these ideas to designing a resource value for the circular economy and net zero? For a strategy to reduce environmental impacts, the first stage is to consider and review all the processes in the product life and next life, and to find solutions to reduce those impacts. A number of strategies can be adopted, and one relatively simple tool is shown in the slide. In the materials choice phase, for instance, you can choose less impacting materials, a biopolymer or a recycled biopolymer or a biosourced polymer. Try them all out. Use waste minimisation to reduce the quantities of material, or a different finishing process, for instance. You could change or improve processing techniques and incorporate issues like transport. In this way, you can slowly build up and assess a different set of options. You apply your own ranking across each stage tailored to the requirements of your particular workplace. If there's any that aren't relevant to you, take them out. The most important thing to ensure is that you capture everything first. I've also attached a link to a much more detailed explanation of this tool, which is from Delft University. And again, you'll find that in the supporting slides if you want to explore further. Right. The final slide before I hand you back to Helena is to get you to think about product sector lifetimes. This is actually quite an important concept in the circular economy. Right, packaging is on the left, construction is on the right. The scale at the bottom is lifetime years of service. So how long do those products stay in service? We have already shown you here that a plastic bottle to a car roof and a plastic bottle to clothing is possible. When designing for the circular economy, think about how that product can be used by other sectors to prolong the life of the plastic moving through from left to right. So, for example, you could go packaging to textiles to transportation to buildings, then chemical recycling to start the route again. Imagine that circular economy in action with these materials. Know your material choices, know your resource value, and know what happens to it next. Most importantly, collaborate to make the circular economy a reality. I'm now going to hand you back to Helena to talk about spin and growing the ideas I hope this talk has raised so far. Thank you.
Thank you, Vannessa. I'm just going to share my slides.
That was great. Thank you so much, Vannessa.
Okay, so SPIN is the Sustainable Production Innovation Network. So this is what we do at WMG to work with SMEs. So when we've been working with our manufacturing SMEs, what we're hearing back is that these companies understand how to deal with quality, cost and delivery in the business, but where to start on sustainability and how to incorporate it into the business models is quite a lot more difficult. So we work with our businesses in two ways, events and cohorts. So the events are to raise awareness. They're an interactive format with 50% speaking, 50% interaction at the moment online, and they're quarterly. Previous themes have been business benefits of sustainability, how to create value from post-industrial waste, and efficient and effective manufacturing. And the next one's on industrial decarbonisation. So you get a bit of a flavour there. For those businesses that want to go a little more in depth and actually start putting things in place, we run cohorts. So this is around peer-to-peer working, and they take place over 6 months with about a 20-hour commitment from the SMEs. I'm going to quickly just go through the outputs here and then focus in on 2 of them with case studies. So starts with a net zero readiness assessment, which is a self-assessment questionnaire showing all the practices from organisation and culture, buildings and facilities, processes, products and supply chain. And the idea being, if you can get to the maximum level across all those questions, you're pretty close to net zero. Then we work with partner organisations who do carbon footprinting and access to grants for putting in improvements. But the meat of the cohort is really in the innovation project. And these are bespoke to each business. So this might be how you can reduce energy consumption in your manufacturing process. It might be how you can reduce waste materials. It might be about how looking at a design and seeing how you could make it more suitable for disassembly. Quite a wide range of skills, because it's more than just me in the team. Then we also have collaboration workshops where we work as the cohort all together, learning a topic, and those are what the businesses want to find out more about. So the current cohort have selected circular economy, factory efficiency, and organisation and culture. Obviously, there's a lot of theory in those kind of workshops. So we aim to do a best practice visit, which is difficult in 2021 at the moment to do in person, but really to see those theoretical practices in real life, see them in the flesh and do a go look-see. And then finally, a roadmap, understanding that the journey shouldn't end at the end of those 6 months, mapping out how we carry on. So, sorry, I've got everyone's cameras over my buttons. That's it. So now the case study. So this is going to incorporate 2 elements of the cohort programme. So first of all, the case study that I'm going to go through was the innovation project for a business called JCM Contracts. But I'm going to show you the GROW model, which is actually what we use in our workshops. So in our workshops, we have an expert speaker come and present a topic. Vannessa's done one on circular economy, for example. And then we break out with the businesses, and those businesses work on what that means to them, what they could introduce in their business, how could they take it forward. So right at the beginning, I asked you to set a conundrum for yourself, or set yourself a question. What is it you want to, what challenge do you want to overcome in your business around plastics, hopefully? If you haven't got one in your head, don't worry, you can use my example, which is let's think about reducing plastic waste in the business. We'll go through GROW, which is goal, reality, options, and will. So let's get going. So goal, what is it you want to achieve on this topic? And we all know about SMART goals. Try and be specific, try and be realistic. What is it you actually want to achieve? What does it look like if you were successful? What would be the benefits if you got this? What outcome would be ideal? When we go through my example, JCM Contracts manufacture washroom cubicles, toilet cubicles, what the doors, what the walls are made of. That comes from businesses like them. These materials, though, are near impossible to recycle. They are actually craft paper, cardboard, which is laminated and fully impregnated with a phenol resin, a thermoset resin, and then a melamine outer. So it doesn't look like layers of cardboard, it looks like a black solid block, but that's actually phenol resin with cardboard. Currently, they throw these offcuts away and they're sent to disposal. They wanted to reduce not only the cost, but the environmental impact of this. So next is reality. This is where you really map out the current situation. I think it's important not to get too stuck in this part, because it can be very easy to just rant here about why something's hard and why something's difficult. So try and keep it quite succinct. What is the current situation? Quite factual. But what is happening now? What is the result of this? Why haven't you achieved your goal already? What steps have you already taken? What might be stopping you? What's contributed to what's going well so far? Are there things going well? So taking JCM, we mapped out for them their current situation, which was that they utilise 70 to 80% of the material coming into their products. So they're actually wasting around 25%. This equates to 1,000 kilograms going into the skip each week, and this is a small SME with around 10 employees. And then that's 48 tonnes a year going to landfill, and they're paying out £7,000 a year. We did a life cycle assessment just on this end of it. So after the product, from generating offcuts to landfill, and we found that their CO2 equivalent emissions were 300 tonnes of that annual wastage. So that was it's quite big for such a small business, and something that they certainly want to address. So what are the options? So here with your problem, think about what could be your first step. What would you do if money wasn't an issue? If you did have a blank piece of paper, if you did have all the time in the world, try and keep your thinking quite wide. Who else might be able to help you? As Vannessa said, collaboration is important. I think you can get so much more skill set by talking to other people. What would happen if you did nothing? That's always a good one to consider. What happens if I don't address this? Which of these options do you think you could really act on as well? And then a really important one I always think is to check yourself and say, and what else? And what else? And what else? So with our ton of offcuts a week, we actually followed the waste hierarchy that Vannessa introduced earlier. So we've mapped out all the options down this hierarchy, or this hierarchy. So first of all, refuse. So let's look at what alternative materials there are. For this business, there aren't any immediately available, but we are highlighting some research projects and new materials which are coming to market for them to bear in mind in the future. But it probably needs to be in their long-term strategy to change away from the phenol-based washroom material. Next is reduce, so waste minimisation. I think it was Vannessa's rule 1, waste minimisation. Here we've signposted the business to a number of nesting softwares which are either freely available or low subscription. So that takes all the orders and runs the computer algorithm to nest them better and try to raise that utilisation rate from 75–80% to more like 90%. There'll be some challenges here about how you identify multiple orders and everything, but it should be something that's achievable. Then reuse. So here we looked at 3 different options of reuse for these offcuts. So firstly, upcycling. Vannessa's worked on projects where they're looking at introducing polymer gears into motorcycle engines. There's the possibility of not using virgin materials here, about taking some of these really difficult to recycle materials and extending their life. So the washroom cabinets is an example. Another example would be wind turbine blades or carbon epoxy parts from aerospace. So something that's got a lot of value in it still. Let's try and extend that value and extend that life as another product. But for the washroom cabinets, I think that would be considered upcycling. For a jumbo jet, it might be considered downcycling. Downcycling, the option we presented was garden furniture. So there's lots of exciting design ideas out there around furniture in the garden, but these materials are inherently lightweight, water resistant, durable. What they don't do so well at is UV, so they would have a shorter life than probably the competitors out there. And then the final reuse option we presented was something around a similar value, which would be composite flooring. So if you think about your sheds and your summer houses, the first thing that often goes is the floor. So how about using these materials as the flooring, and JCM contracts have all the equipment in there to be able to turn these offcuts maybe into interlocking planks, or create a modular design off-the-shelf product for sheds and summer houses providers. And then the final option to be considered is, as opposed to landfill, what about incinerating the waste for energy recovery? This again is a little more difficult for the phenol resins, as they have to come into the kind of advanced end of the spectrum where the gases are scrubbed before they're emitted to ensure there's no hazardous gases emitted. And we actually did an LCA, so the life cycle assessment on this. And there was a reduction in net carbon emissions by about 1/3, but it's still a high amount of emissions. So the business is keen to reduce lower than that. So then the final box of your 4-box model is will, and this is sometimes called way. So where there's a will, there's a way forward. So looking at those options, which options do you prefer? Will this address your goal? When are you going to do this? What could you do today? What could you start right now? Are there any small steps? And I think it's important to get some small achievable steps on there straight away. Try and get some short-term action planning. For JCM, the 2 that we're going to pursue first with them is the nesting, because that should be quite simple to integrate into their business and should yield some results immediately. So reducing the amount of offcuts they produce. And then secondly, the owner is going to investigate some of these reuse options. And she's actually going to start simply by advertising her offcuts on Facebook Marketplace or something like that, and see if they're of use to any other businesses in the local area, and try and create these micro circular economies. The one thing she does have to be wary of, which she knows, is she has to charge for it, because otherwise it's a waste. So she needs to ensure that she's selling a product as a material. So that's the quick whistle-stop tour of Grow. And if we put all of our examples together, you see we've got a nice 4-box model: goal, reality, options, will. And this can be as small or as big as you want it to be. This can be something you do in 20 minutes and come up with a quick action plan, or it can be an in-depth, month-long program to solve a challenging problem. You may not have noticed it, but actually Vannessa was using the Grow model when she did this talk today. So she started with the goal of plastics, let's design for net zero, and then looked at the reality. And here she spoke about some of the good examples there at the moment, some of the bad examples there at the moment, the amount of waste we have out there, what's the current state. She then took us through some options, which was Vannessa's golden rules, from rule 1, waste minimisation, up to rule 6, consider your cost. And then finally, although she didn't write you an action plan, she did present a way forward as to why not try and extend the life of these plastics for circular economy. So that's the end of the Grow workshop, and that's it. You wrote an action plan like a boss, and you can look back on this and do it for your own one if you want, if you didn't manage to keep it. I know we don't have a lot of time here. But now it's time for the final vote. So we've got a poll, which will come up. And this was, Vannessa set them right at the beginning: do you think plastics are a hero or a villain? So yeah, please vote now. Let us know what you think. I think you might be able to tell which side Vannessa and I are on.
Actually, if anybody feels like embellishing on their vote, because we'll wait for a few more to come in, but it's still a nuanced percentage at the minute, isn't it, Helena?
I can't see the percentages, and I
okay, well, it's going to surprise you then.
No, I can just see the poll.
I'm gonna take a little picture of this because it's quite interesting. And I think this in some ways encapsulates, beautifully why we did this whole event, is because it is still a very split decision, and the nuance is you're deliberately putting an oversimplistic question for the point of provocation, but this is exactly the point. So let's see, we've still got a few more, and it's in. So by 60% we have hero, and 40% we have villain. So for me, I think that's exactly I thought it would be a bit split. What did you think?
Yeah, I think it's a very I think the amount of slides that Vannessa and I nearly put on top, it's complicated, was ridiculous, because it is, and I think it was always presented in generally presented in the media as quite simplistic question, and it's very difficult and complicated to answer and address.
I mean, I think in very simple visual terms, but I always feel like the cucumber example really sticks with me. Of that, on one hand, you want to say, boo, no to sort of shrink wrapping vegetables. But then when someone says, but hold on, it extends the shelf life by 2 weeks, then even when you unpack that, you still have this question about, well, was it actually rotten, or was it just a little bit soft? And in which case, if you ask any good chef, they'll be like, well, actually, soft tomatoes are terrific. If you want to make a good spaghetti bolognese, you don't want these hard little bullety things that they grow in the UK anyway. So I think within this, there's always layers and layers and layers to unpack. Please do keep sending in the questions. I wanted to sort of jump into a little bit, just forgive me for showing this little contraption here, which I'm sure most people who are as old as us know that this is a Furby, basically an electromechanical toy. I've had this sitting on my shelf throughout the whole series, as it for me, it's such an interesting reminder that if you look closely, you can see a lot of quite interestingly colored, vibrantly colored plastics on the inside. Some of them are sort of quite soft and flexible. You probably know better than I do. And obviously some are quite industrial plastics. But I guess the provocation for me, and bearing in mind this is still probably a 2000s toy, why is it that when this thing is usually covered in fur fabric, all of this interior, apart from the face and the ears, really is, why is it such high grade colored aesthetic plastic? What is it that you think falls by the wayside in designers? Do you think it's a case of awareness, or do you think it's a case of education in our universities, or do you think it is legislation should enforce this? I think legislation isn't actually going to dictate the interior of a Furby. I think that needs to come from the designer personally. But what do you think? Helena, would you like to start?
Yeah, I think design, I'm not a designer to start with, but I think for years we talked about, you know, designing for purpose, and even designing for manufacture comes second. And now this thought of designing for end of life, almost. It's like another layer added on, and I can imagine it must be a big challenge, and it's probably often dealt with as a secondary skill, maybe, or secondary, and it should be really prioritized as one of the primary parts of design should be looking at that end of life and disassembly.
And Vannessa?
I think I'd actually have a completely different view of this, and I'd actually say this is a company using its scrap material very cleverly. That they've got over perhaps extra volumes of material of bright colours that they've used for their other toys, and are actually.
So you think, for example, that little blue widget there, you think that might well have actually just come off some, I don't know, little doll or something, and they thought, oh well, no one's going to see the colour, we can put that in there.
Yeah, and that would actually be a very standard way that producers had used to get rid of their sort of extra coloured materials.
So do you think, if this product were to be made again in future, do you think perhaps the fact that we are unsure of what's actually happened here, do you think that companies will make it more jazz, which is an industry term, which obviously I've picked up, this professionally, but for the viewers, the jazz is the sort of speckledy, all sorts of different flecks and colors. Do you think that will become a sort of virtue signaling, we are trying to do the right thing, even when you look inside our products, we're doing our best? Or do you think it will come down to the outside of the packaging to explain that this is a B Corp and it's compliant with these standards and ISO certifications, example?
Shall I go first on that one?
Go first, Vannessa, why not?
Again, I think it's to do with supply chains of where those materials are coming from. If the Furby is manufactured where they have a closed loop and where those materials are moving around internally, why would they use jazz? They're actually using up their own waste, their own factory waste. But for food packaging, it makes sense to use jazz.
It does indeed. So actually, I've got a question regarding sort of the vitrimers. I appreciate this is getting into some complex polymer science, but maybe you could just briefly preface this with, what's the difference between thermosets and thermoplastics, and then why is it that you think vitrimers and some of the recyclable variants of this coming through now could be quite disruptive and exciting for the industry? So you're going to have to help me out on who's the expert for this, though.
Vanessa's the expert on that.
Vannessa, okay.
Okay, so vitrimers are a thermoset material, but they can be triggered to go back to a thermoplastic state at their end of use. So it's a massive breakthrough. And they are actually in application now in water sports. There's actually a closed loop system in water sport where they will make I've actually forgotten the exact product. I apologise. It might be a bodyboard or something where it's a thermoset, and it literally goes in a closed loop, becomes a thermoplastic, and they make it again. But because it has the durability of a thermoset, they can keep it in service. But actually, the company who invented that vitrimer for water sports have now been heavily invested in by one of the very big polymer manufacturers, and they're actually looking to turn that to automotive. So a thermoset, apologies, I'm struggling to think here, a thermoset that can be reversed to a thermoplastic at the end of its use actually is such a massive breakthrough in technology. I can't stress what a big breakthrough that actually is for thermoset technology. I'm going to let Helena talk a little bit about thermosets, because she's actually the thermoset expert rather than me.
And this is why we have both of you here.
Yeah.
Yeah, so thermosets are probably more what you'd think of in terms of composites. So composites are often, most often, epoxy and carbon, or you might, and they're used in aerospace and automotive most. So kind of where you need those higher material properties, which is what your thermosets give you, and they give you that by these cross links. But these cross links and these great properties is what means that they are difficult to recycle. So you can't just remelt and reprocess them, which that is a simplistic view, but which thermoplastics offers you. Thermosets don't offer you that. So there's for years, I'd say they've been trying to up the engineering on the thermoplastics. But now what Vannessa's saying is there's actually an option to improve the end of life on the thermosets that these bitumers offer. So kind of coming at it from the other direction.
And I love your example, maybe just to sort of like riff off the back of the fact that you work as much as sort of in an innovation capacity. I really love the story of Innocent, which surprises me, the amount of people who don't know it's owned by Coca-Cola. And as much as the knee-jerk reaction is boo, Coca-Cola, but at the same time, I get the impression that they've managed to play a really interesting partnership game of saying that they've kept Innocent clearly fighting the good fight and trying to be the progressive underdog, young, smaller company. But of course, let's not be fooled. You know, of course, Coca-Cola is looking over the shoulder going, we're watching your market, you know, penetration, we're watching the adoption, we're watching all the social media engagement. It must be still nonetheless exciting and progressive for Coca-Cola to think, yep, the pendulum is swinging, it's gaining momentum. This is something that we can lean into as a huge multinational company for better. So another example briefly for anyone watching who saw the Chris Sherwin talk of Dulux working with quite literally a man in shed inventor to recycle paints. I wonder sort of, do you know, what's your thought on the perspective of sort of small niche players, be it in universities, individuals or startups? How do they interact with companies which are massive? Obviously at the beginning, it must be intimidating. What would be your advice for brokering some of those partnerships?
I think it can be collaboration is the key, because you're all after the same goal. So if you can get something collaborative, it's brilliant. I think that there's going to be a big play around sustainability between these SMEs and these large organisations, because as the large organisations are driven towards net zero, that includes their whole supply chain then. So then they're going to be driving their supply chain to net zero. So, and then they're going to be looking for innovative companies that are already on this journey and on the way and everything. So I think that for what the small guys can do around sustainability and around circular economy, I think the big guys are going to want it. They're going to be seeking it, and they're going to be looking at it because it helps them on their net zero journey. Apart from anything else, you know, quality and cost and everything, just on that subject, they're going to be seeking them out.
So I think maybe to sort of take a different perspective, we've got also a good question from Jan here of, are we exporting valuable plastics to developing countries? And I think, you know, with the news lately, there's been all sorts of scandals around Turkey, just mismanaging them. And I'm not an expert on this, but I'm guessing some of that. But I think a key word here is valuable plastics. How do you respond to that? Of, are we actually missing an opportunity here, do you think, in the haste to just export and forget about it?
I think there was a loophole in legislation that allowed us to do this, and I think this loophole's now closed. I think we tended to export things which we found difficult in this country to recycle. So I mean, the example I would give is multi-layer bottles. So it's no problem recycling a PET bottle, but when you've got loads and loads of multiple layers and tie layers, it becomes very, very difficult to mechanically recycle those.
So just for clarity, a multi-layer bottle is it a blended thing, or is it two things welded together, just for the audience there?
It's made by standard blow molding process, but it actually just makes lots of layers at the same time. So I mean, something like a tomato sauce bottle might have 24 layers in it, and depending on the mix of those layers, it can affect how recyclable it is. So, and I think in the past, we weren't really thinking about the recycling of those products we were making. We are now. So I think, you know, plastics and bottles that were very hard to recycle were getting exported. But I don't think, you know, those loopholes should now be closed, and people shouldn't be allowed to be doing that. If people are buying waste product from us, I presume there must be a value chain for them. I can't imagine any business that would buy waste they weren't able to deal with now. I see the news like everybody else. I see piles of, you know, bales of plastic that I think, what are you going to do with those? I wouldn't know how to recycle those. But hopefully that is now a thing of the past.
And I'm curious, Vannessa, I know that we've sort of talked a little bit offline about your use of yogurt pots as growing things for your tomatoes. Now, I kind of feel this is such an interesting thing, because on the one hand, the image looks very sort of first world, very virtue signaling. And, you know, I'm not attacking you on this. I do the same with my son. I use all sorts of kitchen containers. But, you know, do you think that companies will almost take inspiration from standardized sheets of paper, for example? You mean, do we really need myriad different sizes of mushroom box in supermarkets? Should there really just be 10 different sizes for things? Or do you think as consumers we will revolt somehow? What's your thought on, you know, sort of, should we say, the standardization of the physicality, not just always the material choice?
It's actually quite a strange one. I'm going to use it's complicated. I think from a production and cheapness point of view, obviously standardization allows people to mass produce very cheaply. But I genuinely don't have an answer for this one, other than I reuse my mushroom pots too as plant pots, but that's a completely different matter. What do you think, Jude, on this one?
Well, I guess that's the thing that I sort of feel it's one of those things that seems ridiculous until it isn't, until there's a company and a brand associated with it. And I mean, you know, we've actually got a question here from Jan of, do you have any tips on dealing with ocean plastics? I would say connected to this is, you know, if you'd asked me 10 years ago, would Adidas and Nike be making shoes out at considerable volumes? You know, I appreciate some people might say, oh, it's still a fraction of the percentage of their yield, but we're still talking, if my memory serves me correctly, the Parley shoes were like 11 million pairs of shoes made out of plastic, literally from the ocean. So I would not have anticipated or bet, you know, that would happen. So why is it inconceivable that grocery products might have a second use as things? Because at the end of the day, if you're not buying a plant pot because you get through probably a couple of hundred of these a year, I think that's an interesting way to look at sort of the brand interaction with the consumer. And if you're going to come at it from a marketing perspective, having a yogurt pot that quickly goes in the bin and out of your fridge, as opposed to sitting with your children nurturing a plant, I think any psychologist will tell you that's like free marketing, you know, on your windowsill every day, 24/7. So I think there's something interesting about that. But actually, let me put the question to you from Jan of, do you have any tips on dealing with ocean plastics, just to get back to that question?
So is it possible to clarify that question? Is it what do we do with ocean plastics?
I suspect his layering was maybe how could we interact with the supply chain at an earlier level. So how do we get, sort of engage with it so that we could design so that not as much stuff goes into the ocean? Yes, there's legislation, but is there also a design element possibly?
Can you design in something that makes people want to keep their bottles? I mean, I know, again, we're using the Coca-Cola. They did actually put name labels on their bottles at one point. I don't know whether they still do that. And actually, maybe if you've got a bottle, if I had a bottle with Vannessa, maybe I'd want to keep that bottle. So can designers make people want to keep these products?
I think that's a good one. And just I'm aware that we've got time for just a couple more questions. One from Julian of how can we stop microplastics? I appreciate that's a very broad question, but are there any, to your rules, are there any key things that really, a little bit like tires, most people wouldn't have necessarily considered that tires abrade and create huge problems? Are there things, do's and don'ts, you shouldn't do with various plastic products to avoid microplastics?
I think there's certain designs, there's certain lids which give off more microplastics apparently than other designs. I think about the use. If you're going to have something that's got some abrasion, then you're going to be getting microplastics coming off. It's the same as the tire on the road. So when you're thinking about your design, just think about, is there any tire on the road scenarios there? Even if it's quite a light interaction, is there actually some abrasion?
I think that's a good point. I'm aware that we're a little bit over time here and Nikki's come in. So I guess I got to say thank you so much. I'm sorry we didn't manage to get through all the questions today, but as I always say, that we try to get round to these, and also please do seek out the cheat sheets, of which I think Helena and Vannessa have both doubled the quantity, as been there's so many questions about this. So we're tremendously grateful for that. Thank you both again, and over to you, Nikki.
Yeah, thank you, Vannessa and Helena. What an evocative, really thought-provoking conversation this morning. And I think the amount of people that we've had on this morning is really testimony to that. So thank you for the detail. Thank you for the preparation of this. And thank you to everyone that's joined us. And we'll see you on the next one. Thank you, everyone.
Bye.
Thank you.